Hello everyone, and welcome back to the channel. Today we are going deep into the mountains of Tajikistan, where engineers are building one of the most ambitious hydropower projects on Earth, the Rogun Dam. This is not just another dam. This is a giant wall of rock and earth rising inside a narrow mountain gorge, built to control one of Central Asia's most powerful rivers, the Vaksh River. When fully developed, Rogun Dam is designed to become the tallest dam in the world, a megastructure so massive that it looks less like a normal construction project and more like a mountain being built by human hands. But here is the incredible part. Rogun Dam is not a simple concrete wall. It is not a Hoover-style gravity dam. It is not a smooth concrete arch pushed between two cliffs. Instead, Rogun is a colossal clay-core rock-fill dam, a structure made from millions of cubic meters of carefully placed rock, gravel, filters, transition materials, and an impervious clay core hidden deep inside the dam body. From the outside, you see enormous sloped faces of rockfill and riprap. But inside, the real secret is the central clay core, the waterproof heart of the dam. This clay core is surrounded by filter zones, transition zones, and massive rockfill shells that support the structure against the pressure of a future mountain reservoir. And before the dam could even begin rising, engineers had to solve the first impossible problem. How do you build a giant dam in the middle of a powerful river gorge? The answer was to temporarily move the river. At the beginning of construction, the Vaksh River was still flowing through the canyon. Engineers first had to survey the steep mountain terrain, carve access roads into the rocky slopes, build construction camps, open material yards, and prepare tunnel portals in the mountain walls. Then came the diversion tunnels. These tunnels were excavated through the mountain so the river could be redirected away from the dam foundation area. Crews drilled, blasted, supported, lined, and reinforced the tunnels. They built concrete inlet and outlet portals, guide walls, and outlet protection structures. Only after these tunnels were ready could the river be diverted. Then came one of the most dramatic moments in the entire project. Rockfill cofferdams were built across the river. Dump trucks poured huge stones into the rushing current. Bulldozers pushed the material forward. Excavators placed armor rocks against the flow. Slowly, the river was forced away from its original channel and into the diversion tunnel. For the first time, the future dam site could begin to dry. But drying the riverbed was only the beginning. The original river channel had to be pumped, drained, scraped, cleaned, and inspected. Mud, loose cobbles, weak rock, and sediment had to be removed. Engineers exposed the real bedrock beneath the river, mapped cracks and weak seams, drilled test holes, and removed unsuitable rock. Then they treated the foundation. This is where the project becomes truly technical. Crews drilled deep curtain grouting holes beneath the future clay core line. They injected cement grout into fractured rock to create an underground anti-seepage barrier. They built drainage trenches and inspection galleries. They prepared the base, where the clay core would eventually sit. Only after all of that could the first permanent dam material be placed. And the first material was not giant rock. It was clay. Moist clay was delivered to the center of the dam foundation and spread in thin layers. Sheepfoot rollers compacted it carefully. Every lift was checked for moisture, density, and cleanliness. Then fine filter materials were placed on both sides of the clay. After that came transition zones. Finally, coarse rockfill shells were placed farther out. This sequence repeated again and again. Clay core, filters, transition zones, rockfill shells. Layer by layer, lift by lift, the dam began to rise from the canyon floor. The construction was not random. Every material had a purpose. The clay stops water. The filters protect the clay. The transition zones prevent sudden changes in grain size. The rockfill shells give the dam its enormous strength and mass. As the dam body grew higher, temporary haul roads had to be reshaped directly on the rockfill shell. Heavy trucks climbed the growing embankment. Bulldozers spread rock. Compactors densified each zone. Surveyors checked slopes and levels. The dam slowly became a giant engineered mountain across the gorge. But Rogan is not only a dam, it is also a hydropower plant hidden inside the mountains. While the dam was rising outside, another huge construction effort was happening underground. On the upstream side, engineers built the intake structure, the place where future reservoir water would enter the hydropower system. They excavated rock benches, poured reinforced concrete base slabs, built gate bays, installed wall sections, and began carving the gate chamber into the mountain. Behind the intake, pressure tunnels were excavated deeper into the rock. Crews drilled, blasted, removed broken rock, installed rock bolts, sprayed shotcrete, added drainage, and slowly pushed the tunnel forward toward the future powerhouse. Then, on the downstream side, they opened access adits into the mountain to reach the powerhouse cavern, and this cavern was enormous. It was not excavated all at once. First came a small pilot heading at the crown. Then the top heading was widened. Then the cavern was deepened bench by bench. Each newly exposed rock surface was supported with bolts, mesh, shotcrete, and drainage. Slowly, a cathedral-like underground industrial hall took shape. Inside this giant cavern, crews excavated turbine pits, shaped draft tube passages, poured reinforced concrete foundations, installed crane runway beams, assembled the overhead traveling crane, and then began lowering massive hydropower machinery into place. Spiral casings, stay rings, turbine runners, shafts, generators, stators, rotors. Each component had to be lifted, aligned, checked, and secured with extreme precision. Then came the waterways. Steel-lined penstocks were installed inside the pressure tunnels to carry high-pressure water toward the turbines. Tailrace tunnels and outlet portals were completed, so used water could return downstream to the river. Transformer caverns, cable galleries, control rooms, and switchyard equipment were built to carry the generated electricity out of the mountain and into the grid. Meanwhile, above ground, the dam continued rising toward its final form. The upstream face was armored with large riprap stones to protect it from waves and reservoir action. The crest road was shaped and compacted. Monitoring instruments were installed to track settlement, seepage, pressure, and movement. Drainage systems were completed. The switchyard was prepared. The intake gates were installed. Then came the moment every dam project works toward. The river diversion system was closed. The reservoir began to fill. Slowly, water rose against the upstream riprap face of the dam. Engineers watched every instrument. They monitored seepage, settlement, pressure, intake gates, drainage galleries, and downstream tow flows. Nothing was rushed. A dam of this scale does not simply turn on. It is tested step by step. Once water reached the intake, the pressure tunnels and penstocks were filled carefully. Air was released. Valves were tested. Leaks were checked. Then, inside the underground powerhouse, the first turbine was allowed to spin. At first, it was only a test. Then came synchronization. The generator connected to the transformer and switchyard under controlled conditions. Voltage, frequency, vibration, temperature, and pressure were monitored. More units followed. One by one, the plant moved from construction to commissioning, and from commissioning toward commercial operation. And when Rogun finally operates as a complete system, the result is breathtaking. A giant rock-fill dam holding back a turquoise mountain reservoir. An intake structure controlling water at the edge of the lake. Pressure tunnels carrying water deep into the mountain. Turbines spinning inside an underground powerhouse. tail race outlets returning water downstream, a switchyard sending electricity across the region. All of it built inside one of the most dramatic mountain landscapes in Central Asia. Rogun Dam is more than a construction project. It is a battle between engineering and geography. It is a structure designed to control a mountain river, store water, generate power, and reshape the energy future of Tajikistan. And what makes it truly incredible is not only its height, it is the sequence. First, the river had to be moved. Then, the foundation had to be exposed. Then, the mountain had to be drilled, stabilized, and sealed. Then, the dam had to rise one layer at a time. Then, the underground powerhouse had to be carved from solid rock. Then, water had to be captured, controlled, tested, and transformed into electricity. That is why Rogun Dam stands as one of the most extraordinary hydropower projects in the world. If you enjoyed this journey inside one of the world's most ambitious dam construction projects, make sure to like this video, subscribe to the channel, and turn on notifications so you do not miss the next mega project story. Because in the next video, we will explore another engineering wonder that most people never get to see from the inside. Thanks for watching, and I will see you in the next one.